Hello everyone, welcome to our online video tutorial series, and in this series we will learn about class 11 maths topic relation and functions. In this particular video we will learn about the problems based on the domain and range of the functions. Okay, let's start today's class. So functions, as we discussed in the previous video, let's revise once again. So what are the functions? Functions are a mapping from the set X to set Y, where X is the set of domain and Y is the set of codomain. So let X and Y be two non-empty sets. A function from set X to the set Y is a correspondence which associates each element of set X to exactly one unique element of set Y. As I told you in the previous video, dear students, a relation is said to be function if and if only that every X of domain must have some unique image in the Y. So if any relation that satisfies these two conditions will be a function. So let this is set X, and the same example I am quoting here. So this is X belongs to some states of India: Goa, Haryana, Punjab, Tripura and Maharashtra. Whereas set Y represents some capitals: Chandigarh, Panji, Mumbai, Raipur and Agartala. And if I relate them, Goa's capital is Panji, Haryana capital is Chandigarh, Punjab capital Chandigarh, Maharashtra capital Mumbai and Tripura capital is Agartala. So that way it relates that we can check that every element of X is having an image there, and that image is unique. See, this image is unique for everyone. So none of the elements of the set X is having a double image in the set Y. So now on the basis of the definition, we have to tell which of the following relations are function and give reasons. If it is a function, determine its domain and range. So here this functions, I represented this one, this roster form in the arrow diagram, so it will be easy to understand. So the ordered pair first elements 2, 5, 8, 11, 14 and 17 I listed here, and the second element I listed here. This is 1 only. And you can see that all the elements are associated with 1 only. So now is it a function? So we will check it. Whether every element is having an image. 2 is having image 5, 8, 11, 14 and 17. Yes. First condition satisfied. Second condition is that unique is having. Second condition is that image unique. What is the image of 2? 1. What is the image of 5? 1. Image of 8? 1. So for every element my answer is 1. That means none of the element is having image more than 2 or 2. So it's a unique one. So second condition is also satisfied. So both the conditions are satisfied. Yes, it is a function where every element of its domain is having unique image in Y. Now what will be the domain? 2, 5, 8, 11, 14, 17. That means elements of the first set. And what is the range? Range is the set of images. So this is 1. Now which of the following functions are relation? So let's check it. So again I make that arrow diagram and represented them. So can we see this? Every element of X is having a unique image in Y. Yes, it is a function. And what will be its domain? Its domain will be 2, 4, 6, 8, 10, 12 and 14. While the range will be 1, 2, 3, 4, 5, 6, 7. Next one. Here let's draw the arrow diagram, and here I can see that element 1 is having two images. It's not unique. What is the image of 1? Some may say answer is 3 and the other may say answer is 5. So f1 is equal to 3 and the value of function at 1 is also 5. So image is not unique. That's the reason it's not a function. Correct? So no need to write domain and range when it is not a function. Now a function is defined by fx is equal to 2x minus 5 and we have to write down the values. It's very easy. We have to find f0, f7 and f minus 3. So function given, this is given. Let's give the input x as 0. So if I give input x as 0, it will become f0. So x is to be replaced with 0, 2 into 0 minus 5 and answer will be minus 5. Similarly, when I will give the input x is equal to 7, it will become 2 into 7 minus 5, that is 9 and minus 3 also. So our answer will be minus 11. So that's our answer. Next is a function t which maps temperature in degree Celsius into temperature in degree Fahrenheit. So defined by the function of Celsius is 9c by 5 plus 32. And we have to find out the value of T0, T minus 10 and the value of C when temperature is given 212. Let's find out. So this is our given function, given map. So this is given. Now first we have to find out, we will try to find out T0. So let's put give the input C is equal to 0. So if I give C is equal to 0, then replace this C with 0. 9 into 0 by 5 plus 32. So 9 into 0, 0 plus 32. So our answer will be 32. If I have to find T minus 10, so I have to give input C is equal to minus 10. So let's put it. So if I put minus 10, then 9 into minus 10 by 5. 5 to the 10. So it will become minus 18 plus 32, which is equal to 14. And the next part is we have to find the value of C when temperature is 212. So temperature is given. Let's replace this function. What is that? 9C by 5 plus 32. Okay, take the 32 to the other side. Subtract them. It will become 9C by 5 is equal to 180. And take 9 by 5 to the other side. It will become 180 into 5 by 9. 9 to the 18. So C will be 100. So let's find out the domain and range of the functions in detail. Dear children, it's a very important concept, and in many of your competitive exam they will ask the question based on the domain and range of the functions. So first we will discuss about the linear functions. As you know, linear means whose sketch will be a line. So I'm drawing here, I'm defining a function from R to R, that means domain is real number and codomain is also real number. And what is a function, linear function? That is ax plus b. Y is equal to fx is equal to ax plus b, for each x belongs to real number. So domain is very much clear that domain will be real number, and we will try to find out what will be the range. So let me sketch the curve for the linear function. So this is the curve for linear functions. So here I have taken the equation y is equal to x plus 2. So this will be my sketch. Okay, and if this is my sketch, you can see that x is all real number and the value of y will also go to all real number. Correct. At any point you can check that. So y will keep on increasing, x will also accordingly, and if I go downwards, so I will keep on decreasing. So domain will be all real number and range will be all real number. What if I change the curve? So if I change the curve, if I take 2x plus 2, then again same thing. If I change this constant term, so curve will move, but it will exist for every value of x. If I take this coefficient negative, then what will happen? Only the direction of the line will change, but it will exist. So domain and range will be all real numbers. So hence for all the linear functions such as y is equal to x, y is equal to 2x minus 3, y is equal to 5 minus 3x, whatever it may be, just you have to check that whether it is a linear or not. And if it is a linear, you can directly write that domain will be all real number and range will also be all real number for every linear function. Now let's discuss about the quadratic function, and as you know, quadratic function is ax square plus bx plus c. Okay, and domain is all real number. So let's see what its range will be. So here this is my a quadratic curve. So this is x square plus x plus 1. So what if I take this only x square, then it will become, yes, it's an upward parabola. So whatever the value of x, coefficient of x or the constant term, it will remain an upward parabola. So in that case, the value will be on the positive side. Okay, and if I take it negative, then what will happen? If minus x square it is, then you can see that it will become a downward parabola. So if it is only x square, then it will become negative side of the y-axis. So it depends the coefficient of what is the coefficient of x square, that a parabola will be upward or downward, and range will be based on that only. So if my question is only x square and I have to find out the domain and range of this function x square, then you can see that it will be from 0 to infinity, and domain will be all real numbers. Curve exists everywhere. Only problem is that it will range will be on the either 0 or the positive side of the y-axis. It will not go to the negative side. If my curve is x square, then its domain will be all real number. So domain in all the cases will be all real number. But range will depend upon the value of a, b and c. It may be a positive one or negative one, depends on the function. So if I take here x square, then I will say it will from 0 to infinity. It was an upward parabola like this. Now we have to find the domain and range of this one. So it's a quadratic as we discussed now. So domain will be all real number, and as you remember, it will be a downward parabola because coefficient of x square is negative. So to find the range, what we will say that, see, domain is all real number, that means x belongs to all real number. So x square will be either positive or 0, and minus x square will be less than equal to 0. Remember, whenever we multiply the inequality by a negative number, the sign of inequality will get changed. So here I change the sign of inequality, which was greater than equal to, now it become less than equal to. So if I add 4 both sides, then it will become 0 plus 4. And what is this? This is my function. So function will attain the values less than or equal to 4. That means its sketch will be like this. A downward parabola and maximum value will be 4. So this is 4. So what is my range? From minus infinity to 4. So on a number line, if you try to understand this, function will attain the value less than 4. So this is 4, less than 4 will be this side. So minus infinity to 4. So I'll write down range will be minus infinity to 4. See whether 4 is included or not. Yes, so put the close. So that was all about today's class. Hope you enjoyed this. Thank you very much for being with us.